shape of particle. Friction coefficient for shape of particle. Third, we compare the results of pumice and coated pumice. Coated pumice has a different friction from pumice. Different friction coefficient. From the results of X direction are similar. And the results of coated pumice of Z direction are 1.3 times larger than those of pumice. From these results, friction coefficient has little influence to the bucket forces. We thought that reason is that not only sliding motion but also rolling motion of the particles occur in the pipe. I return one slide. We found out that friction coefficient has little influence to the bucket forces. So comparison to PP particle and pumice means that shape of particle mainly cause the difference. Sorry. And finally, we compare the results of pumice and gravel. Gravel has a different density from pumice. Different density. The results of X direction are similar. And the results of coated pumice of Z direction are 1.3 times larger than that of pumice. From these results, density has little influence to the bucket forces. Summary. The results of DEM simulation with irregularly shaped models are close to those of model experiments with irregularly shaped particles. Second, reaction forces mainly depend on the shape of particles. Finally, friction coefficient and density have little influence to bucket forces. Our future work is considering the shape of model. For example, triangle-shaped model and tetrahedrally shaped model are considered. And we will research about the load capacity. That's all. Thank you for your attention.
Questions?
I have a question regarding the shape of the bucket. You simulated it without teeth.
Without teeth?
Yeah. A normal bucket working in that condition has teeth mounted on the edge.
Okay, please where are you? You mean the
Yeah, that simulated the bucket you had in your laboratory. Was that with teeth or without teeth?
You mean the teeth is
Yeah.
We thought the teeth
Without the teeth.
the teeth influence is very little, and so first we don't liquid teeth in simulation.
Okay.
Other questions?
Yeah, from the video and the talk, looks at mainly you're trying to simulate dry materials. Dry material.
Dry material.
Yeah, dry particles.
Dry particles.
Have you or any of your colleagues tried to simulate either soil or particles which have got cohesion and are sticking together? know, when if the soil gets wet,
Yeah.
then when it goes into the bucket, it stays stuck in the bucket. Is this a problem that you think you could solve?
Yeah.
It is an issue with buckets.
Yes, the wet soil is problem. No. So the wet
soil.
Wet soil is
It sticks
very
together
difficult.
in the bucket. Is
Yeah.
this something that you could look at with this technique?